Hey, everybody, it's Chief Meteorologist Brad Panovich. I'm here at the WCNC studios, and we're getting ready for an exciting event today. Virtually, we're going to watch the Mars lander, hopefully, land on the Martian surface today. It's pretty exciting. I was with my kids this morning watching the initial launch of Perseverance back in July, believe it or not, back at the Cape. And it took all this time to get to Mars. And it's very interesting to see some of the parameters that they had to deal with back in July with the COVID pandemic going on and trying to launch this in the window they had. And I'm going to be joined in this virtual party today from Candice Jordan over at the Schiele Museum in Gaston County. And Candice, we were supposed to be together, well, at least 6 feet apart, at least today. But the ice storm and other things kind of kept us a little bit apart. But I wanted to bring you in here and talk a little bit about the Schiele Museum. You've got a very unique title over there, which I think is really cool. You're a meteorologist, but you also get to do a lot of cool science stuff over there. So why don't you talk a little bit about your role over there and what folks can do over at the Schiele Museum?
Yeah, so hey guys, my name is Candice Jordan. I'm the planetarium administrator and I'm also a meteorologist here at the museum. So basically, if you look up, I handle everything that's above your heads, whether it's weather or whether it's space. So here at the planetarium, we have different shows, ranging from like talking about Mars rovers, and we have a show called We Are Aliens. We do things called the Sky Tonight. So that's where I can literally show you the stars, planets, constellations that you'll see in the sky tonight, which is amazing. It's a lot of fun, and I love hearing people who come back and they're like, I was able to find Orion's belt. Thank you so much. Such good stuff.
I think that's the cool thing about and I think that's the cool thing about like astronomy and some of the space stuff is it's like weather in a way, where it's something you learn and you think, oh, it's science, but then you can take it home and apply it to something you can literally see in your backyard. So that's really cool. What kind of programs do you guys do for like kids and parents? Because I know they're looking for things to do right now, being cooped up. And maybe talk a little about your hours and how you guys are handling the whole COVID pandemic and social distancing over there.
Yeah, so this month is Fossil February, so we're doing fossil digs every day of the month in February, which is awesome. So, if you want to try to find some ancient relic, you can find it here, and that's great for kids. They love it. They can sift through all the cool stuff. Planetarium shows are running daily. So we've got the We Are Aliens, which is great for kids, and the Sky Night's also great for kids. We have a program called Early Explorers. That is for our younger guys. That's for ages 2 to 5. So if you've got toddlers at home, that's a perfect program for them. They do like crafts and songs and books and everything. We're doing our best here, guys. We're trying to keep 6 feet apart. Everybody has to wear a mask. We have different capacity restrictions. So, especially if you want to come, and especially on weekends where it's a little bit busier, make sure you reserve your tickets online. That way you'll be able to come. But yeah, lots of good stuff going on. We're trying to keep things as COVID-free as possible, but also give you a little education on the way.
Yeah, and today's an exciting day. I know you're like me; you're kind of a space geek as well as a weather geek. Today's an important day. I mean, what are your thoughts on the Mars rover and how cool this is going to be to see this happen? I mean, I think we all remember the previous rover, and some of the pictures and video. I think the thing that I'm most excited about is that we're going to have some high resolution 4K video at times, even though delayed. It's still got to come from Mars, but almost real time.
Yeah, so this whole spacecraft's going to have about 25 cameras on it. 2 of those is going to be on a helicopter, which we'll talk about soon. And then, like you said, some of these are very high resolution. There's some color cameras. So it's going to be nice to kind of, this rover is literally going to see for us. It's going to have some microphones. We can hear things. So it's really going to try to replicate those senses. The robotic arm will be your touch, and then chemical composition type sensors are going to be like your taste and smell. But this is a pretty good day.
Yeah, and I think people are going to ask, well, why are we sending a rover again, right? It's collecting a lot of information about the Martian surface. I mean, if we're ever going to go there, which that's our plan, we've got to kind of scout out, what's there. And I think a cool thing, and not people immediately think Martians and aliens, but the goal is to like search for some signs of life either previously or currently on the planet. And I think people immediately think science fiction movies with aliens, but we're talking about even small single cell organisms or bacteria. That's the kind of things we're looking for, right?
Yeah, so this thing's going to land in this place called the Jezero Crater. So way back, early Martian history, Mars used to have liquid oceans. And so this crater was a lake. And so we're landing in a place that was an ancient river delta. So, the whole theory is where there's water, there may be life. We need water to live. So with that notion, that's the reason they picked this spot, because if it had water once before, did it have ancient life? And so we're looking for things called microbes. There are things that you literally see underneath a microscope. You're not going to see little green Martians like dancing around on Mars. None of that. It's things underneath a microscope, but really important things, because, if you can find a single cell organism, given enough time, what can that become?
Yeah, and that's kind of how life begins in most locations. That's how it started here on Earth, So a good question from Ned is, will we be able to watch the landing this time from Curiosity, or will we have to get a delay, or will it just be still pictures? I think that's a great question.
Yeah, so the NASA Perseverance rover, it's going to land at 3:55 today. But at 3:55 today, it's not like we're going to be seeing it actually like on the surface. It takes about 11 minutes or so for the radio communication to get from Mars to Earth. So just know that anything that happens is going to have an 11-minute delay, which is also the reason the rover has to land by itself. It's 7 minutes to land, and it's 11 minutes to talk to it. So it has to land completely by itself.
Yeah, and I think the interesting thing, I was talking with my kids today, especially my daughter, she was fascinated by this launch in July and the landing today. And I remember one of the JPL folks talking about, they were worried the pandemic was going to delay the launch. And they said we couldn't delay it because one thing I think people don't realize, there's a very short window to launch the Mars, only available every 26 months, if I'm correct. So if you miss that window, you basically have to wait 2 years to launch again.
Yeah, so think about like runners, think about like a high school track meet. You know how you've got the different lanes on a track. Well, Mars is a little further away from the sun, so it's on one of those outer lanes, and we're on one of the little inner lanes. And so even if we run at the same speed, one's going to be moving a little faster around the track because there's less track to take up. So with that being said, we perfectly had to align this mission. So we hit that 300 million miles. It only takes 7 months versus 9 months, which doesn't sound like a lot, but the cost of fuel and the added weight to get off of Earth is immense. So the less fuel you can have, the better.
Yeah, I think he said something like on the order of $500 million difference, which is, and he admitted, he goes, NASA has a tight budget. We cannot be messing around. Now, one of the cool things about this rover, and we talked a little bit about it, it has this helicopter called Integrity, I believe. And the cool thing about the names, and people are asking, Perseverance and Integrity were both named by students, right? They actually submitted essays. And Perseverance is a great name during COVID. I think that would have been like the greatest name for it. But it actually was picked before COVID-19 was even a thing.
Right. Yeah. So it was, I think there was like 28,000 essay submissions that they looked at, and they finally picked out, the one that was Perseverance. And then there was also the helicopter, which is called Ingenuity. And, they're awesome. Like, students got to pick this out. That just goes to show, like, if you have a 7-year-old at home, they can choose the name of a rover. You don't have to go through immense training to be an astronaut to do something with NASA. Like, they love incorporating regular people into these really cool space missions that are going to go down in history books.
Yeah, and I got the name mixed up there, Ingenuity, because I think the thing about that, because I'm actually more excited about Ingenuity because I have a drone, and I just picture this thing as like a drone. But having been a drone pilot, one thing I can tell you about the atmosphere on Mars, it's like only 1% the density of Earth's atmosphere. So if you're a pilot or know anything about air density, that's incredibly hard to fly in when you have such little atmosphere. So this thing had to be like super light, and it had to have really fast rotors. And maybe you don't know this. How fast do those rotors have to spin?
So they are going to spin 8 times faster than a normal helicopter would here on Earth. I think that was like 2,400 RPMs. Don't quote me on that, but it's something like that. Ridiculously fast. And also those blades are 4 foot long, and there's 4 of them. So huge blades, really fast. And one thing about it is that it's only about 4 pounds here on Earth, the entire helicopter. So it's 1.5 pounds on Mars. So like you said, super lightweight. This is going to be our first time doing flight on another world. And really NASA is just like one milestone at a time with this, because it is our first time flying somewhere with a completely different atmosphere.
Yeah, and I think that's amazing. I think I've heard some of the JPL people, NASA people refer to this as like a Wright brothers kind of moment, because we're actually doing manned flight in a different atmosphere on a different planet. That's a whole nother, way of thinking about this. And the cool thing about this rover, and this helicopter, is that it's got a solar panel on the top that charges a battery, and it can only fly, I think, for like 90 seconds at a time or something like that. And I saw one of the worrisome things, and we'll have to watch with this, is that it's going to be landing close to night, and they're really worried about that battery making it through the first Martian night, because it's super cold. And so they have a warmer or heater on it to keep it kind of from not losing its charge. And that next day when the sun comes up is going to be really crucial.
Yeah, and so one thing you'll notice if you kind of follow along once this rover lands on Mars and stuff, they call them sols. So you'll hear like Sol 1, Sol 2, and that's because the Martian day is a slight bit longer than an Earth day. It's like 24 and a half hours, roughly speaking. So they'll call them sols instead of days. So that's kind of a neat little thing. But one thing we have learned, we had solar panels on the rovers before, but this time they also have, think of it kind of like a little generator on there, and it uses plutonium-238. And so that actually helps to heat it, because there's planet-wide dust storms on Mars. If you think the weather's bad here, there's a dust storm that takes up the whole planet on Mars. And think about it, you block the light, you don't have power. So they also have kind of like the backup stuff with the rover as well.
Yeah, it'll be fascinating to watch. So if you're just tuning in to our stream here, you can see we've got a box there with the live presentation from NASA coming up. We're just kind of setting this up. We're not going to talk over NASA too much, because we really want them to kind of take it away, but we wanted to kind of get, do this virtually and kind of share this with everybody. And, hopefully a lot of kids out there are going to watch this, either watch it live, or the great thing is they can go back and watch this. I have NASA TV on Hulu and on YouTube. You can go back, because I'll tell you, just my kids get really fascinated with this stuff. It's one of those things I think sparks interest. And I told my daughter and my son when we were down at the Cape a couple of years ago, we saw the whole planning for the Mars missions. And I told them, I said, when I was young, after I was born, the moon landing was like, going to the moon was like the generational thing. And I told them, this is going to be your generation's event, to go to Mars. And that got them really excited. And it's a kind of thing that can spur an interest in science. I really hope the kids out there get a kick out of this, and kind of ask questions, and like, hey, how does this rocket work? And what is a sol? And how, what is the weather like on Mars? Because these are all great things that will get them interested in science.
Yeah, I agree. And one thing too, especially if you've got young kids out there, you don't have to become an astronaut to do something with NASA.
Yeah.
There's people who have made those solar panels, people who have made weather instruments for the rover. There's so much like STEM out there that you can get a part of any of these missions in the future in different ways. So like, take your math and science skills and run with them.
Yeah, and that's a cool thing about NASA TV, which we're going to go to here in a moment, is they were talking about the literally thousands of people's life missions it was just to get this rover to go to Mars. This has been their life's work. So think about everything from the engineers to the technicians to some of the field supervisors, the people that work for ULA, which is the rocket launch, people down at NASA. I mean, it's just amazing the number of people and all the different roles they've had to get this going. So I think that's a great point. And it takes all different skill levels in education. It's like, we always joke, you don't have to be a rocket scientist to get involved in rockets, believe it or not.
Not at all.
It takes a lot of different perspectives and fields. So Candice, I think we're going to wrap up our commentary here as we toss it to NASA here in a minute. But anything you want to leave people with before they start watching this, or something to be on the lookout for today?
Yeah, just share this with everybody. This is a historical moment, and this is a positive thing that's going to be happening to the past year that we've had. So, just stop what you're doing. It's okay. Take in the Mars rover landing and just smile. It's awesome. It's a positive thing.
Yeah. And I would say one thing that I would leave too that I saw in the launch, and I missed this totally at the launch the first time, Candice, they actually put a plate on the side of the rover as a tribute to the healthcare workers that were working during this pandemic. So I thought that was really, really cool. So right now on Mars, there's a plaque on the side of the rover as a tribute to everybody fighting this COVID-19. So I think that's amazing.
And I think there's like 10.9 million names that signed up to be on the Mars rover. It's on like a little tiny chip on the rover. I will say I'm in there. Woohoo! So hopefully you at home are as well. And if not, keep up with NASA's website. When they do their next missions, like they love to put people's names on there.
So someone from Mars is going to call you about your car warranty. Is that what you're saying?
Exactly. Intergalactic. Yeah, thank you.
Yeah, it's coming. We get worried if my caller ID says Mars, I'm going to get a little worried. All right, so we're going to toss it off to the NASA coverage here, and as Candice said, please, if you can, share this link right now because NASA is going to go on. We're hopefully going to see live pictures, and I say live, as Candice said. There's an 11-minute delay, which to me sounds amazing because when I have a 5-second delay on my streaming service, I get upset, and it's coming from down the street. We're talking, this is coming from another world. And so the fact that it's only 11 minutes away is just amazing.
Awesome. We're getting people on here saying hello and thank you for doing this. Oh, I'm on the plaque as well. Yay. That's exciting. Thank you guys for tuning in today.
Yeah, you know what I find? I think this is like what I find with weather as well. There is a small group of people that geeked up about this as much as we do. And I love seeing that enthusiasm. Like I remember, during the conjunction with Jupiter and Saturn and how excited I saw people that my neighbors that I never knew had any interest in space were all of a sudden just mesmerized by it. So I think that's really cool. And every time the space station goes over, I just get one more person that says, man, thank you for saying something because my kids are just now asking me a million questions and I don't have the answers for, which is fine. That's
why you can come to the Schiele Museum because I will totally nerd out on you about the International Space Station.
Yeah, because that is really cool. So thanks everybody for tuning in. We love seeing all the great comments here. And again, don't worry, the stream's not going away. We're going to switch to NASA coverage here. And again, before we leave, Candice, just a quick shout out for the museum because I think you're a hidden gem in our community that some people don't know about. So if you can get over to the Schiele Museum and go talk with Candice, she's going to get you hooked on science and especially the planetarium, which to me, as a kid, I love the planetarium. I could have gone to that every day of the week and been happy.
Awesome. Yeah. And put your comments below as the NASA TV's going, tell us what you're thinking. We want to kind of know what's going on in your mind too with this. It's awesome. We want to know, what are your questions? What can we help answer? That's the whole point of this too is, not just to show you the coverage of the lander or the rover landing, but also, help answer your questions. I'm sure you got, some kids at home that are like, why is it doing this? Why is it doing that? Yeah. We're your go-to people.
Yeah, that's what we want to see. We want to see the kids' curiosity get piqued and then go, Mom, take me over to the Schiele Museum so I can learn more. That's exactly what we want to see.
Oh, Paula's too sweet. Thank you, Paula.
Oh, I know. Yeah, it is great. It's one of Candice is great, and she's a really great asset to the community over there. And the Schiele Museum is just amazing. And just over there in little old Gaston County, just so there's a ton of stuff to do over there. I love going over there now to Gaston County because that place is hopping now between Belmont, Mount Holly, and Gastonia. There's a lot to do over there, so maybe make a day of it if you head over that way. So again, thanks for tuning in.
Jump away.
Yeah, and it's so close, and someday we'll have light rail over there. Who knows, eventually. So we're going to go to the NASA coverage here. I'm kind of watching them because, no offense to them, but I like us talking more than them. But I'm hoping we'll get some new information from them because they do a great job of kind of giving you the behind the scenes of what's going on. And this will be interesting because you're going to see a lot of worry on people's faces because there's a lot of scientists there right now that this is their baby, Candice, right? And they're they're waiting to see something go right or wrong. So they're very nervous watching everything.
Well, it's like it's like watching your child do, an onstage player or play at a band concert for the first time. And you're just like, oh, come on, please hit that note, please. You're going to do it. You're going to do it. It's like there's nothing you can do now. It's all in their hands. Well, that's what the rover's like. So one question I've had people ask me is, why are we bringing another rover? This isn't our first one. We've had Sojourner, Curiosity, Spirit, Opportunity. So why again? I want you to think of it in like terms of iPhones, right? So you remember the iPhone 3, like way back when, and we thought that was like the best technology ever. But when you look back now, it's like, oh, that's like so old news. Like the iPhone 11 or whatever one we're on now is like so much more advanced. Same thing with the rovers. For the time, it was awesome because we've, totally revamped our technology. And so if we send this new technology to Mars, we're going to uncover new things. So think of it in kind of that terms. That's why we're doing a new rover.
Yeah, and and the whole on the surface, keep something there permanently, and we're continuously replacing the previous device to keep things going because we don't want that drop off. And so I think that's also really important. Candice, real quick before we go off to NASA, I keep feeling we're going to toss to that, but I'm like, I want to see something interesting happen first. Let's talk a little bit about this long-term plan for us to go to Mars. And, this mission that this really is like the new space race, right? To get the first person on the planet.
Yeah. So, if we're going to send humans to Mars, first off, it's a 7-month journey at best, So when you think that's 7 months there and 7 months back. So what do humans need? Well, we need air to breathe. We need water to drink. We need food to eat. That's a lot of weight to put on a rocket. So one thing that this rover is going to have on it is this thing called MOXIE. And you've probably heard a lot of weather acronyms. Space has just as many acronyms. But MOXIE stands for the Mars Oxygen In Situ Resource Utilization Experiment. Try saying that 3 times fast.
Wow.
But basically it's called
MOXIE sounds a lot better.
Right. And so what they're trying to do is they're going to try to see if they can convert the carbon dioxide in the atmosphere of Mars into oxygen. Now, who breathes oxygen?
Yes.
We do, yeah. Also, they can use it for rocket fuel for getting back home. So the thing is, you don't want to have to carry the fuel to also make a return trip. If you can do it there, that saves a lot of weight. That's a great thing. So, that's kind of what they're doing. They're also going to capture soil samples. And I think there's about 30 different ones that they can capture. And it'll just be stored inside the rover until we can get a return trip kind of scheduled. But they're going to, it was amazing. I watched this video and it was amazing at how clean they had to keep that room. You don't understand, like, when you go in a hospital and they've got all the gear on right now trying to stay clean, like it's even more than that. And it's because they want these sample containers to be completely sterile. So that way there's no bacteria from Earth, because that's the problem. If there's some bacteria from Earth in there and then we find signs of life, well, the big question is it originating from Mars or did it come from us? So super sterile containers, but they're going to be able to capture some of this Martian soil and capture it, and then we can return it later and analyze it.
Yeah, it's truly amazing to think of the engineering and the work that has gone into this, and that you hope everything didn't get damaged or jostled in the launch, in the trip out there, in the landing. There's like a bazillion things that could go wrong, right? And it's amazing to me sometimes when stuff does go wrong. Like we've seen it with a lot of big missions. Like I even think of the Hubble Space Telescope, huge problems with mirrors and stuff. We're still able to make some functioning use out of this from a far enough way away that they could do it remotely. So it's pretty amazing that the engineers can still try to fix things even if something goes wrong, right?
Yeah, so it's like you preparing for a hurricane. You got your hurricane preparedness kit there, right? Same thing. They kind of have like this preparedness kit in their head of like, oh, well, if XYZ happens, we can do this. And they're going to try to account for the main problems that they think they may encounter. Of course, things happen, but they try their best. They try.
So, if you watch a lot of science fiction movies, The Martian's a great movie. There's actually some pretty good science in there that's and some Hollywood entertainment, which I think is great because it'll give you a lot of perspective on what it's like to be on Mars, but also some of the things that NASA and the astronauts are going to have to go through to get out there. That's a real sacrifice for whoever ends up being the person or persons that end up going to Mars. So it's amazing. I think a lot of questions that I see often from people, and I'm not seeing it here, but a lot of people ask me, like, why do we do this? Like, what's the point of going to space or going to Mars? And, I have my ideas, and I can tell you there's a million of them and a lot of them. But, Candice, why do you think we do this besides just the science and the achievement of it?
I think it's the most basic human thing. We're curious. You look up at the stars and you don't just look at them and be like, oh, great, there's white dots in the sky. You're like, oh, that's stars. I wonder how far away that star is. Are there any planets around that star? I think we're always constantly asking why. We're like toddlers, but we're adults. We're always asking why.
Yeah.
So I think that's kind of the most fundamental thing is, why? And then I think also the competition. We're also very competitive beings. I mean, you think about the space race. It was literally two nations that were trying to go after it, see who could do it first, And so I think there's that little element of competitiveness, though I think nowadays there is also some unison. So not only are we landing on Mars today, but last week, the United Arab Emirates and China actually went into orbit around Mars. And so we're all kind of working together to figure Mars out.
Yeah, I think one of the things I tell people is there's actually a financial interest to do this as well, because some of the things they will find and use in this mission will end up being the next iPhone or that part of our next car or flying car in the future. All the technology that comes out of this that ends up in our everyday lives. But the other thing is, it's just like you said, it's like, a lot of times kids ask, why do we need to study history? So we learn something about ourselves, right? And that's the thing about going to other planets. We might find something about the origins of Earth or the origins of species on our planet that is on Mars. And we might rediscover something about ourselves that we never knew because it was hidden on Mars and something. So I think that curiosity is really important.
Well, it's the same reason back in October, this thing called OSIRIS-REx. Sounds like a dinosaur. It's totally like a spacecraft. But it went to asteroid Bennu. And what it was doing, it was grabbing a sample of this asteroid because, it's not a planet. It's just like a space rock. But, what's inside that space rock? It's going to tell us a lot about origins and different things like that. So, that's actually coming back in 2023, I think. So, NASA has so many hands on so many places in space, and it's awesome. But our next door neighbor is obviously the most curious one we have.
Yep. I know. I'm always fascinated by that. Now, my son is really fascinated with gold mining and gem mining. And so when he heard about the benefits of some of these asteroids possibly having valuable material on them, he's like, Dad, we need to go send a ship. And I'm like, yeah, but buddy, if there's a ton of it, then it wouldn't be valuable, right? So, but there could be some material that we don't have on Earth right now that could be a new metal, a lightweight material, something that could end up saving lives or being used for protection here. So I think that's the other thing people take for granted. There's might be something out there, some new element that we can use on Earth that could really be beneficial to mankind.
Exactly. I mean, you think everything that we know of in science right now is based around Earth because that's the only place we've really had to study. So like you said, there could be more elements on the periodic table that we just don't know about yet, just because we haven't found them. But speaking of Mars, I want to tell you a couple cool things about Mars. So we were talking about the atmosphere is very different. Gravity is only about 38% as strong as Earth. So like I was telling you about the Ingenuity helicopter, it's 4 pounds on Earth, but it's only like 1.5 pounds on Mars. So you would weigh a lot less on Mars. So if you're looking for a diet, Mars is definitely the place to go. And average temperatures. So, it's been a little chilly around here. We've had this awful cold rain for what seems like forever. But the average temperature on Mars is actually negative 64 degrees. So, right. The lowest, it kind of ranges from negative 200 in the dead of night, upwards to about 80 degrees at the equator. So, the 80 becomes tropical.
And I'm sure it only snows north of 85 there as well.
Right, exactly. I'm sure there's an 85 line on there somewhere.
Yeah, there's some Martian going, it never snows at my house here until I get north of this crater.
Could you imagine forecasting on Mars, though? That would be crazy. And that's another cool thing to think about, too, is like, once our technology gets well enough, like we go to Mars, we're going there more consistently. Say we get humans on Mars, we're going to need a meteorologist for Mars. Like, who wants to be a Martian meteorologist? Me.
Yeah, their weather there is crazy. You're right. They have tornadoes and dust devils and giant dust storms, and their storms last days. Like we think about a 10 or 15-minute thunderstorm. They've got storms there that will last a week. I mean, so it's crazy to think about the weather there. And you're right. Just like anywhere we go, if weather's going to be part of the mission, you're going to need somebody who understands. So there's meteorologists and atmospheric scientists in NASA now trying to figure out how to forecast, probably even model the Martian atmosphere so that when they go there, they'll be able to be prepared or at least have the equipment to be safe when these storms do hit.
Yeah. So, and that's the whole thing. Like this whole mission, I've heard the term astrobiology. So if you love biology, maybe you're not a physics person, that's A-okay, because I know rocket science has a lot of physics in it. But, this is astrobiology we're doing. We're looking for life on another world. So think about anything you can do on Earth, you could also do on Mars. So, pretty cool.
I know. I'm just thinking of all these jobs. So it is a really cool day. Candice, thank you so much for doing this. And we're going to monitor the comments on this stream even after we're off. So everybody watching, what you're seeing is an animation of what it should look like. And we're also going to go to NASA, which is their live feed right now. So we're going to go to their feed here for the rest of this. And hopefully I'm going to be watching here as I'm putting the forecast together, Candice. So I'll be keeping an eye on the comments as well. Because I'm really excited. I mean, this is cool. That I got geeked up this morning when I got up, and I'm like, I was worried about ice for a while. Then I'm like, I was almost glad that the ice wasn't that big of a deal, because then I was like, now I can focus on the Mars lander. Because I'm like,
I can safely nerd out today.
Because I'd hate to be here nerding out on this, and like there's ice and trees out there. So it's kind of been a nice thing that we didn't get as much ice as we expected. And it's still a miserable day out there. So it is a good day to maybe stay inside and watch this landing. And get the kids, share this with your friends. If you're watching this right now and you've got grandkids or neighbor kids or your friends or family, tell them to watch this. This is going to be an amazing event. It is historic.
Yeah, I think this totally counts as virtual day learning, in my opinion.
Yeah, absolutely. And I saw somebody actually comment on YouTube, anyone else having to watch this for school. So there are some students on here to watch this. So yeah, you see the NASA feed below me there. I think that's the animation of what is actually happening.
So I know, let's see.
I can't tell for sure. Thanks for bringing that full screen.
Thank you.
Yeah, so this looks like
that's 7 minutes of terror it's trying to show.
Yeah, because it's funny because sometimes they do this with the launches when they don't have actual visual. They'll run an animation that is actually built off of the diagnostics and the data coming in from the spacecraft, which I think is really, really cool to see. So I envision we're going to have some pretty amazing pictures today. And I just wonder what that first image is going to look like, Candice. And it's probably going to be all over the place. It's going to go viral tonight at some point when those first images come out.
Well, we need something to go viral that's like not bad. We need like just Martian all over our social media feeds. Awesome. Yeah.
It's going to be a selfie of some kind, we know, right?
They actually have had the rovers take selfies before, which I think is just amazing. I think that brings in like the younger generation with the technology.
Yeah.
Because I mean, why not make a selfie of the rover?
Yeah, I can't wait to see that picture. I think because I'm curious to see the quality versus the previous missions. And I think you will realize like why we're going back. The difference in the picture is probably going to be pretty dramatic.
Yeah, I agree. And, getting, like we've been talking about, I think they're showing kind of some animations there of, the 7 minutes of terror. So if you haven't heard of that, it takes 7 minutes for it to go from the top of the atmosphere to the ground. So that little part you're seeing right there, that's the sky crane that will actually lower it onto Mars. So that's kind of the last step, and that sky crane will go away. That will be at about 2 miles an hour. That's how fast that sky crane will be moving. But it's going to be moving, the whole spacecraft at the top of the atmosphere is going to be moving at about 12,500 miles an hour. So you think, you're trying to stop on the interstate, and you're going like 65 to 0. Here it's going from 12,500 to 0 in 7 minutes. That's, it's a lot.
Yeah, I'm hoping they'll do more of the, because they have a big mock-up of the rover at JPL and at NASA. I'm impressed how big those tires are. The wheels are like bigger than me, right? They're giant. So to put that in perspective, I think that looks like a toy on these videos, but it's like the size of like a truck, right?
Yeah. So this whole rover, without not counting the arm, is about the size of a small car. So like 10 foot long, 7 foot tall. So it's taller than most people. It's huge. And this is the heaviest rover that we've took to Mars to date. So it's about 2,200 pounds. So really heavy, but every little ounce on there has some purpose. There's nothing on there that is just frivolous, like, oh, let's just paint this red because we like it. Like, no, nothing is frivolous on that thing. So yeah,
you get that question a lot. Like, why does it look the way it does? Why doesn't it look cool? But you're right, because it's efficiency. Everything is built to do something, not for looks.
Yeah, exactly. I mean, you think every ounce you add is money added. So, if you want to make it to where you're not spending as much money, you're really, really efficient with it. And so that is one reason it does look the way it does.
Yeah, I told my daughter today when she asked that question, she said, "Dad, why does it look so weird?" I said, "Well, it's got a mission." I said, "It's like your Pinewood Derby car. Remember, it didn't matter what it looked like; it mattered how fast it went." And she's like, "Oh yeah, some people made their cars to look good, others made them to go fast. This is meant to serve a purpose, so we want it to do what it's supposed to do."
But I also think that that's what makes it intriguing as well, is the fact that it does look the way it does. It doesn't look, it's not like a Tesla on Mars. It's
so funny. So I was thinking if Elon Musk built this thing, it would look completely different.
Right. It would have a different look. But you also think it's not, the rover's not flying, so it doesn't need to be aerodynamically, built. But those bigger tires, it needs that, because if you look at the surface of Mars, there are tons of rocks and boulders. So it has to be able to encounter things like rocks and boulders. Because literally the last thing you would want was to get this thing off Earth, 7 months later, it perfectly lands and gets stuck on a boulder. That would be the biggest epic fail. So it has to kind of account for that.
Yeah, there's a really cool, I think Tony Rice sent me this. Tony, he sent me this cool game. They've got the whole crater kind of gridded out with numbers, and you can guess where it's exactly going to land, because it's kind of like, we know it's going to be somewhere in the crater, but we don't know the precise spot, because you don't know what winds and little shifts in that landing process could move it. But it's kind of a fun game. You can pick which square in the crater it's going to land on, actually.
That is awesome. And the thing is even the scientists who are in mission control right now don't even know where it's going to land, because this thing can course correct itself up to about 2,000 feet above the ground. So it actually has a camera that's going to be looking down at the ground as it's descending. And it'll sit there and determine what is the safest and best location for me to land. So, if it realizes that there's a big old boulder there, well, that's not good to land on. So it'll tell itself oh, let's scoot over to the left or right or however. So that's kind of really neat that it's intuitive enough to know, this is safe, this is not, let me course correct. So technically mission control doesn't even know the exact, location of where it'll land.
Yeah, that's going to be, I think that'll be cool to watch, to see where it ends up actually landing. So, well, thank you so much, Candice. This has been amazing. I mean, I could talk all day about this, but actually, I actually have to go to work and do some more stuff. I'm at work right now, so I'm getting ready to do the forecast. But quickly tell everybody where they can find you again, and if they want to, the best way to contact you guys to come check times and all the different events and things you guys do over at the Schiele Museum.
Yeah, so we're at the Schiele Museum. We're located in Gastonia, so it's a hop, skip, and jump away from Charlotte, right down Interstate 85. Trust me, to the left, it won't snow. To the right, it will. And we have a planetarium here. We've got a dinosaur exhibit. You can come sock skating right now. Our farm is also here as well. So lots of good stuff. I do encourage you to get your tickets online at SchieleMuseum.org. So SchieleMuseum.org. That's a best place to look for times, dates, events, programs. But we're open 7 days a week, so we are here. We're ready for you guys.
Yeah, get over there because it really is a really cool facility, and I can't wait to take my kids over there again. So thanks again, Candice. We're going to toss it off to NASA TV live here, and I think when do you think are the first images we're going to get before we go to them?
Oh, let's see. One of the first images. I know it lands at 3:55.
Yeah.
So 11 minutes after that, I think realistically, and they're going to also have they need a second to breathe. They're going to have to figure it out. The rover's going to have to land. I would say it's probably going to be at least 5 o'clock before we see any real-time images. They may try to push out some from the cameras as it's landing, but I think that they're honestly going to leave those alone. Let's let it land. We don't want to mess anything up by trying to get pictures. Let's let it do its job safely. Once it's landed, I think that's when they're going to try to grab data.
Yeah, I think you're right. I think they might hold some back until everything's good to go, and then there might be a big dump of pictures that come out, and we'll start getting more stuff. But so even though the stream is up now, they're going to lead you through the whole process. Candice is right. We're probably not going to get those first real images until I'm hoping on TV here at WCNC, we're going to bring them to you and try to turn them around as quick as we can. If we get them before the 6 o'clock newscast, but I think they're going to end up online immediately. NASA's social streams are pretty amazing. They have a great team down there. So I think you're going to see them get pushed out almost immediately. And I know everybody watching this will be doing screen grabs and posting them the second they come out, because I'm going to have this up on my desktop off to the side. So if I miss a weather hit, you know why.
Well, and I think too, like we were talking about, this is their baby over at NASA. So just like you know, when your kid scores the first goal or something, you're taking pictures and you instantly post them. I think they're going to be the same way. They're going to be so proud of their baby landing on Mars that they're like, let's get a picture. Ah.
Yeah. So I enjoy that too, and seeing all the scientists jump for joy when something happens successfully, because you can kind of see their emotion and their life's work come out all at once. Hey, this is what I've been working on. Look at this. So it's just a joy. And I'm sure their families feel the same way, because a lot of them had to make huge sacrifices to work on this mission, especially during the pandemic.
Yeah, exactly. Yeah. And, it's pure excitement. You can see it's not just a job that they come into every day and it's I got to be here today. Let me make a solar panel. They really put their whole heart into it. And so when this is successful, it's not only a success for NASA, but it's probably a personal success for them as well.
Yeah, I saw that today when I think the director said, during COVID, they gave everybody the option that if they didn't feel safe, that they, wouldn't hold it against them if they wanted to get out. He said nobody wanted to leave the program. So that just tells you how committed people were. And even one of the moms who was one of the answers, she said it was tough because, I was spending more time with my kids. They were home at school. And so they do the same things we're all going through, right? They've had to do this and try to get a rover to Mars. So imagine your work from home has been tough. Try doing it through NASA and getting a rover to another planet. That's just stunning.
But they did it. And it was amazing to see the people who, they were like, I'm in my closet now with my office and I'm sitting here working on a rover code. And I'm just like, that is awesome. You can do that from home.
It is truly amazing. And so I think that's a testament to just the ingenuity and the kind of achievement that this is. This is probably a bigger achievement than we even realized, since it all happened during the pandemic, which is just amazing. And I think, as you mentioned, Candice, I think this is a really bright spot in everything that's happened in the last year. This really shows, and that's why the name of this lander, Perseverance, is just, it's amazing that's the name that was picked out ahead of time. But it really is a testament to what they've gone through, what we've all gone through, and what we're going to see today to see this thing come to fruition.
Yeah, and we got a comment here saying the rover is taking this whole social distancing thing pretty serious. Yeah, I mean, we recommend 6 foot apart, but 300 million miles is also okay too.
Yeah, it's. I hope I was thinking about this today. We always worry about contagions from other planets. I hope we didn't send COVID-19 on this thing, and I know that was actually some of the things the scientists were. Because like you said, they had to have clean rooms. They did not want any contamination in this for scientific reasons, but also, we don't want to contaminate another planet.
Yeah, that was the whole reason. If you remember Cassini a few years ago with Saturn, Cassini went and it studied Saturn and some of its moons. And what we did is we purposely crashed it into Saturn when we were done because Enceladus, one of the moons of Saturn, is one that scientists are really interested in. And the last thing you want to do is that spacecraft to go rogue, something happen, an asteroid like bumps it and it crashes into another world and carries Earth germs with it. So that was like, I was relating that with COVID, like, you know, we don't want to spread germs in space, so we crashed it into Saturn because we know that there's no life there. Same reason, guys, you wash your hands and wear a mask. You don't want to spread germs, so we do it in space too.
It's a really important lesson. So thanks again, Candice. This has been great. And as you can see the NASA feed going below me, you got somebody that looks like zooming in from their house as well, as we talked about. You're going to see a lot of this in this feed. People are still, it's a pandemic, and these scientists are all over the place because you've got, you know, people think about NASA's footprint across the U.S., all the different facilities they have, from JPL to Houston to Goddard to up in D.C. to Florida. I mean, to, you know, Huntsville. There's just, I mean, they're spread out all over the place. It's, I think when I was in New Orleans, Michoud, where they tested the rockets for Artemis, I mean, it's just amazing that all the NASA's just spread out. There are pieces and parts of these projects spread out over many states across the entire country.
Yeah, and thousands upon thousands of men and women who are working tirelessly to make all these projects happen.
Yeah. So thanks everybody for tuning in. We're going to toss it off to the NASA coverage. And again, if you have questions or comments, feel free to put them into the chat or the comments section. We're going to have this running, so we'll be able to see them, and we may not be able to come on camera and answer them, but we can type back and give you some answers. So thanks again, Candice. This was great. We definitely got to do this again for another event.
Yes.
Maybe I'll actually, once this, you know, COVID thing calms down, we can get out there more often and do some fun watch parties and stuff with you guys out there.
Exactly. We got to do something weather related.
Yeah, definitely. It'll be fun. So thanks again. Head to the Schiele Museum if you can, guys. I want to thank Candice and everyone out there. They've been amazing. Sorry we couldn't be out there today. I was going to do all my weathercasts from out there, which would have been awesome. And I secretly wanted to do it just so I could hang out at the museum and look at stuff. So I was selfishly looking forward to this more so than probably a lot of people. One of the perks of our jobs, right? Get to do some cool stuff.
Right.
But again, the feed will be going full screen here. We'll keep it up, and James is going to pull up the audio for us. You guys will hear it. And again, if you have any questions, feel free to contact us. We'd love to answer them. So take care. Be safe out there. And again, enjoy this, because this is a momentous occasion for everybody as we land on Mars. It's going to be crazy.
Stay curious, guys.
To track Perseverance during landing.
The communications infrastructure supporting Perseverance's landing is quite complex. We've rallied a truly global network of relay and communications assets to help us capture and record those precious minutes of entry, descent, and landing, or EDL. We receive a stream of engineering telemetry via these communication assets that helps us see and understand exactly what's happening. Perseverance sends direct-to-Earth X-band tones, each of which provides us with indications of critical entry, descent, and landing events. During entry, descent, and landing, we have 2 Mars orbiters listening for the ultra-high frequency, or UHF, signals from Perseverance. These orbiters relay these signals to deep space network stations on Earth, Madrid in Spain, and Goldstone in California. The Mars Reconnaissance Orbiter, or MRO, has reconfigured its software to perform a type of relay called bent pipe. This will provide us with near real-time telemetry during entry, descent, and landing. We have coverage from the Mars Reconnaissance Orbiter from just before entry to a few minutes after landing. The telemetry we receive will be delayed by the time it takes light to travel from Mars to us back on Earth. Additionally, the Mars Atmosphere and Volatile Evolution spacecraft, or MAVEN, is recording these UHF signals and will be relaying that recording hours after landing. MAVEN will be covering us from around the time of cruise stage separation until a few minutes after landing. We also receive what we call heartbeat tones, which are indications that the spacecraft is alive and progressing throughout entry, descent, and landing. It's important to note that while unexpected, we could lose our communication links and still land safely. Because Perseverance is doing entry, descent, and landing completely autonomously, she doesn't need our help to joystick the landing. The communication links give us added visibility.
And you can see Chloe hard at work inside Mission Control right now. Perseverance's landing might look like the system the Curiosity rover used back in 2012, but landing on Mars is difficult. There's always a risk involved. Here's what needs to happen for Perseverance to touch down safely in Jezero Crater.
Nothing can be taken for granted when you get to Mars. There's a lot of things we just don't know.
Space always has a way of throwing us curveballs and surprising us.
I mean, until we get the data that says we're on the ground safely, I'm going to be worried that we're not going to make it.
Entry, descent, and landing is often referred to as the 7 minutes of terror, because it takes about 7 minutes to get from the top of the atmosphere of Mars to the ground safely.
The spacecraft has to do all of this by itself.
There are many things that have to go right to get Perseverance onto the ground safely.
There's a lot counting on this. This is the first leg of our sample return relay race. There's a lot of work on the line.
Starting about 10 minutes before atmospheric entry, we get rid of really the spacecraft part of the rover that's been supporting us.
We come screaming in to the Martian atmosphere at 12 to 13,000 miles per hour.
And the heat shield is what dissipates all that initial energy through friction.
The vehicle will continue actually flying itself through the atmosphere. It's sort of like a transforming vehicle that went from spacecraft and now it's kind of like an aircraft actively guiding itself.
When we're going slow enough, we deploy a parachute.
It's the biggest supersonic parachute we've ever sent to another planet. It's critical for slowing down the vehicle.
Perseverance's entry, descent, and landing borrows heavily from that of Curiosity.
But fundamentally, Perseverance is a different rover. She's bigger, she has different instruments.
We've added a lot of smarts on the inside to make it more capable so that it can deal with the landing site that we've given.
The science team identified Jezero Crater as basically an ancient lake bed and one of the most promising places to look for evidence of ancient microbial life and to collect samples for future return to Earth. The problem is it's a much more hazardous place to land.
When you look at Jezero, all you see is danger. How do we go to a site that we never thought was safe enough to go to before? So the heat shield, which has protected us all the way through entry, is no longer necessary. We need to get that off so that we can actually see the ground. And we can see the ground in a couple different ways.
Perseverance will be the first mission to use terrain relative navigation. So while it's descending on the parachute, it will actually be taking images of the surface of Mars and determining where to go based on what it sees. This is finally like landing with your eyes open. Having this new technology really allows Perseverance to land in much more challenging terrain than Curiosity or any previous Mars mission could. Amongst the rocks and the craters and the cliffs, these things are hazardous to the rover, but these are the things that are interesting to the scientists.
Once Perseverance has figured out where she is, we jettison the back shell and parachute and light up our rockets. Those rockets help us steer to a safe landing spot that's nearby.
That descent stage takes us all the way down to about 20 meters off the ground.
That's when we start the sky maneuver. Once the rover has hit the ground, the descent stage will cut loose from the rover and fly away to a safe distance. But surviving that 7 minutes is really just the beginning for Perseverance. Its job, right, being the first leg of sample return, to go look for those signs of past life on Mars. All that can't start until we get Perseverance safely to the ground. And then that's when the real mission begins.
With us now is Al Chen. He is Perseverance's entry, descent, and landing lead. Al, you were part of the Curiosity rover landing. Does it get any easier the second time around?
It absolutely does not, especially when considering we're trying to land the biggest, heaviest, and most complex rover we've ever built at the most dangerous landing site we've ever attempted. Jezero may look great and promising from a science perspective, but it's absolutely treacherous for landing. There's a cliff wall that's about 200 feet tall that runs right through the middle of the landing site. There are craters full of sand that even if we landed in them, we would not be able to drive out of. And there are rocks to the east and actually all over the place, rock fields. That would be a bad day for us if we were to land on them.
Now, Al, what new technology makes this type of dangerous landing possible?
Perseverance is carrying two new technologies that are really kind of under the hood smarts that are allowing us to land at this treacherous landing site. The first is range trigger. That's the ability, we've given Perseverance the ability to decide for herself, based on where she is, when to deploy the parachute. Previously, we used to deploy parachutes, that supersonic parachute, based just on navigated velocity. But now Perseverance has the smarts to figure out where she is and deploy that parachute at just the right place to make sure that we shrink where we could come down. That actually reduces the area, that error ellipse, where we can come down on the ground, from something that was on the order of 15 miles long by 12 miles wide for Curiosity to about 5 miles long by 4 miles wide for Perseverance. So that's quite a bit of reduction. Second, the next piece of technology that's helping us land there is terrain relative navigation. In the past, after we've popped off the heat shield, we've taken pictures of the ground as it's been coming up, but we haven't really done anything with them. This time, Perseverance is carrying a camera to take pictures, but also a kind of second brain to help it figure out what those pictures are telling it and match it up with an onboard map from a satellite. That allows it to figure out exactly where she is. Suddenly, then, she can then fly to safe spots that are nearby once she really knows where she is. It allows the site to not have to be as flat and boring as a pancake as some of our past sites have been, the entire area we could come down. Now we just need little pieces of that site to be small enough and safe enough for us to land in safely and fly there after we've gotten rid of the parachute.
And we also have a social media question coming in. Sansakari14 on Instagram is asking, how does the sky crane decide where to move itself after the payload lands?
After the payload lands, after the rover touches down, the sky crane, the descent stage, which is that rocket-powered jetpack above it, the first job, of course, is to make sure you don't hurt the rover. So it'll turn forward or backward so that the engine plumes don't pass over the rover. So it'll come up and start to turn. And it'll go in whichever direction is closest to north. So it can either go forward, if that's the way north is, or go toward the rear of the rover, if that's where north is. And it'll fly about a third of a mile or so away.
Thanks for talking to us today, Al.
Thank you very much.
Now, let's head back to Mission Control for an update from Swati.
Hi, Raquel. So remember that command that we sent at around 11:35 to turn the transmitter off? We are just about to get confirmation that Perseverance has received the command. The command took 11 minutes to go to Perseverance, and then the reply took 11 minutes to get back from Perseverance to the ground. So we should hear any second now that we have officially turned off the transmitter. And after that, we will be about 4 minutes from the start of entry, descent, and landing mode. At this point, we will transition from the cruise approach mode to entry, descent, and landing. And that means our travel from Earth to Mars is done. And now we just need to get to the surface. So far, things are looking good.
Great.
So this is CAD 3, ready to show estimated miss distance for OD 152.
Copy, EDL phase. We'll come back.
Go ahead.
Flight 8. Wait. Our tracking stations have all confirmed the results of the transmitter drive off and in lock one way. Copy, Ace. GDS flight. Flight GDS. At this time, I'd like to disable the alarms before EDL main. So please disable all the alarm files and start a new downlink session. Copy that, ECP. Copy that, proceeding now.
Confirmation that we are now officially one way and the transmitter is off.
Rover mission has helped shape the other, starting with the landing of the Pathfinder more than 20 years ago, leading up to where we are today with Perseverance. Perseverance Deputy Project Manager Jennifer Trosper has worked on every Mars rover mission, and she joins us now. Jennifer, how does Perseverance fit into the history of exploring Mars?
Thanks, Raquel. It's great to be here. Well, Perseverance is NASA's 5th rover on Mars, and I've had the privilege of working on every one of them. And the very first rover was the Sojourner Rover we sent in 1997, and it was the size of a microwave oven. And even at that small size, Sojourner was able to transform the way that we explore Mars from stationary landers to small roving robots that go from place to place, just like a geologist would on Earth. So once we had that roving capability, then we sent our twin rovers Spirit and Opportunity. Spirit and Opportunity were tasked with finding evidence of ancient water on Mars. Now they did. They're great explorers, and both of them found ample evidence that water had once existed on the surface of Mars. But we had a question. Another question then was Mars ever habitable if water had been there? And that's when we sent Curiosity. Now, Curiosity was a major upgrade to our rover fleet. She's the size of a small car. She landed with the Sky Crane system instead of airbags. And she also carries along her own analytics lab, and she's still operating today. And during her exploration, she has found evidence of a habitable environment in an ancient lake bed on Mars. So now we're sending Perseverance. Perseverance is tasked with answering the question and looking for evidence of ancient microbial life on Mars. And in order to do this, she has to be the smartest and most capable rover we've ever sent.
Speaking of Perseverance, can you tell us more about how Perseverance is smarter than its predecessors?
Yes, we've made a lot of upgrades to help her along with the surface mission. One of them is for her autonomous traverse capability. When I say autonomous traverse, I mean we tell her where we want her to end up, and she has to figure out the safe and best way to get there. In order to do that, she uses her cameras, algorithms, a computer. So we've given her another computer, we've upgraded the cameras, and we've upgraded the algorithms. Now she drives 3 times as fast as Curiosity could drive in this autonomous traverse mode. In fact, her average daily distance for driving, about 200 meters, is close to the maximum distance any rover has ever driven in a day on Mars. So she's fast. Another thing that we've done, which is the most significant upgrade that we've made, is the sample caching system itself. Curiosity has a robotic arm, like Perseverance has a robotic arm, but on the end of Perseverance's robotic arm is a coring drill that will take rock cores, transfer them into sample tubes into the rover, where another robotic arm will take those tubes, will seal them and store them, and eventually drop them on the surface of Mars for future return to Earth.
Great. And we also have a social media question about Perseverance. Erica AS on Instagram wants to know what the wheels of the rover are made out of.
Great question. Well, you may think we make them out of some material you've never heard of. It turns out they're made of aluminum. Now, Perseverance's wheels are a little thicker than Curiosity's, but they're actually both made out of aluminum.
And one more question for you. Can you tell us more about the importance of where you are right now in the building?
Yes, I am above, on the second floor, above the cruise mission support area that you've been watching. And this is the surface mission support area. So as soon as Perseverance lands, all commands, this room will take over. It will become headquarters for operating Perseverance on Mars.
Thanks for taking the time to talk to us today, Jennifer.
Thank you.
Now, we now know Perseverance's place in history. Let's take an up-close look at the rover with Mars 2020 System Testbed Engineer, Elio Morillo.
Thank you, Raquel. Standing in front of the Mars 2020 Perseverance scaled model. As you can tell, this vehicle is about the size of a Mini Cooper. These wheels are obviously black here and they look like rubber, but they're actually fully made of metal. These wheels are designed to allow us to climb over obstacles and of course climb over hills and minimize the amount of slipping once we're traversing on the surface of Mars. Here in the front of the rover, we have the sample caching system. And of course, at the very front end of this is the robotic arm, which this entire system is arguably the most complex robotic system we've ever sent outside of Earth. Here at the tip of the arm, we have a turret which contains a suite of instruments along with some drills and coring capabilities that will allow us to do contact science once we get to the surface of Mars. Not only that, this robotic system is equipped to collect samples about the size of a piece of chalk that then eventually will be stored inside of the vehicle and dropped off in a later location so that an eventual mission can go and return these samples to Earth, something we've never done in the past. Here in the front, we have the remote sensing Mast. Something of note is that this mechanism is going to be stowed upon the touchdown on the surface of Mars. And one of the first critical activities we do is deploy this mechanism. This mechanism includes several cameras that are going to give us some of the most breathtaking images we've ever taken on Mars. Along with that, we have some lasers as well as a spectrometer. They're going to allow us to do some remote science. Here you see some of these extrusions that are part of a larger weather suite of instruments that will allow us to characterize the local climate around Perseverance. So that's a quick tour of the rover, but I gotta get back to work. So back to you.
Perseverance is collecting samples of Martian rock for future return to Earth. We've heard that scientists have been wanting to bring Martian samples back for many generations. And here to talk a little bit about that is NASA's Planetary Science Division Director, Lori Glaze, who joins us now to talk about the role Perseverance will play in NASA's future goals. Welcome, Lori.
Hi.
Now, as you just heard, we've heard that scientists have been wanting to bring back these Martian samples for a very long time. Why do we need to bring them back?
That's really a great question. You know, we actually have examples of Mars already here on Earth that came here as meteorites, but we don't know exactly where they came from on Mars. And then they also have had to make the trip from Mars to Earth. And so they got altered during that time. And then during their entry and descent into the Earth's atmosphere, that also changes what those rocks are like. So being able to go to Mars and actually collect a sample where we know exactly where it came from, and we know we can preserve it and keep it pristine and carry it all the way back here, this will be incredibly important to help us answer questions about the geologic history of Mars, understanding how it formed and evolved, and also really important questions about whether or not life actually existed on Mars 3.5 billion years ago, and whether that life, if it existed, has been preserved in the surface of Mars.
Now, Lori, these sample tubes that Perseverance is going to be collecting, they're the cleanest things ever created on Earth. Tell me a little bit about that.
Oh my goodness. We worked so hard. The team here at JPL is absolutely incredible to assure that those sample tubes are incredibly clean. One of the main goals of this mission is to be able to detect if there's actual life that's preserved, ancient life preserved in those rocks, in those samples. And we definitely don't want to be carrying, our own DNA off to Mars and then bring it back here to confuse our scientists when they're trying to study those samples. So it is an incredibly clean set of equipment that's been sent there. As you said, the cleanest thing we've ever sent into space.
Now, this is a very complicated campaign. Can you break down for us how it's going to work and if there's any international partners working with us?
You are correct. The Mars sample return campaign is incredibly complex. In fact, it's probably the most challenging thing we've ever tried to do. But we're definitely not going to try and do it alone. We have great partners with the European Space Agency. And the way this campaign is going to work, well, Perseverance is the first step. Chapter 1 is going to Mars and collecting the samples. Chapter 2 is going to be a sample return lander that we hope to launch in around 2026 to 2028. And that lander, it'll be an American lander carrying a fetch rover that's provided by European Space Agency. And that little fetch rover will drive out and pick up the samples that Perseverance left on the surface of Mars. And the fetch rover will bring them back and load them into a rocket that we call the Mars Ascent Vehicle, which will be the first ever launch from another planet. And it will launch those samples into orbit around Mars. In the meantime, European Space Agency will have an orbiter that's in orbit around Mars that can rendezvous and capture those samples and then bring them back to Earth for us to study back here in our amazing laboratories.
A lot of firsts, it sounds like, Lori. And another first, how is Perseverance and the Mars sample return mission going to help the future exploration, human exploration of Mars?
I'm so glad you asked that. I think we're going to get a lot of great information from Mars sample return with, again, being able to land the heaviest payload we've ever landed on Mars will be that sample return lander. That's critical to us learning how to land humans on Mars. And then we are definitely going to want to be able to launch the humans back off of Mars. So that Mars ascent vehicle is going to be critical, that first step of the first launch from another planet.
So exciting, Lori. And speaking about the Mars generation, we're now going to take a student question for you from Livia.
Hi, my name is Livia, and my question is, what made you want to study Mars, and why are you working so hard and willing to wait so long for a sample? Thank you.
Oh, Olivia, that is such a great question. And I enjoy Mars just because it can tell us so much about how our solar system formed and evolved. All of the planets can tell us different parts of that story, and Mars is a really key piece of that. And one of the main reasons we're willing to wait so long to get the sample back is that we've got great new scientists that are all about your age, and in about 10 or 15 or 20 years, you'll be the generation that's going to actually get to work with these samples. When they come back, you'll be the scientists and engineers that will be the next generation to change how we think about Mars and how we think about life in the solar system.
That was a great question, Lori. Reach for the stars, future little scientists and engineers. Thank you so much for joining us here today, Lori.
It's my pleasure. Thanks.
Back to you, Raquel, for another mission update.
Thanks, Marina. The cruise team for Perseverance controls the rover on its way to Mars. And moments ago, they handed it over to the landing team. And it looks like team leaders in mission control are about to talk to both teams. So let's listen in.
The CBM change, as I mentioned previously, is to the EDL reserve two-way non-coherent route.
Activity.
Copy flight.
EDL phase, go ahead.
I'd like to see pep talk, I guess, to the team. All right. I'm terrible at pep talks. I think my reputation precedes me there. And look, I know this hasn't been easy, right? I'm not even sure we've even been all in the same room at the same time. I mean, I'm staring at folks across the internet as well. Even now, right? Yeah. Voice check. Okay. I do want to just extend my heartfelt appreciation from the EDL team to the launch cruise team. You've done everything we've asked for, right? I mean, you've battled anomalies, you've dealt with Cepheids, you've done everything. You delivered a healthy spacecraft to the place that we want to go, and she's right on target, right? You did the last maneuver literally 2 months ago, right? This is pretty incredible, in my opinion. And she's armed with the right information to help us land. Doing the parameter update last night, we're ready to roll. You've done everything right. And you've put up with us too, right? You've put up with our eccentricities and the things we like to do in EDL land. So I very much appreciate that. So you all should sleep in on Friday since you guys have earned it. Thanks for literally and figuratively putting us in the right position to succeed. And let's land on Mars together.
Copy EDL phase. And as flight director, I also would like to thank the whole team, cruise ops, EDL ops, EDL team, and the surface ops as well. It's been an amazing journey. I think we all know that. And it's been my honor and pleasure to work with you all side by side. And your tireless efforts and endurance in the face of our challenges has been truly, truly inspiring. So kudos to you. Mission, would you like to say something?
Yeah, just echoing the same words that Al and Magdi have mentioned. You guys have overcome great obstacles in the last 6.5 months, and it started with an earthquake in this room on launch day at L-20 minutes. So I can't be more proud than all of the achievements that you guys have pulled off in the last 6.5 months. Whatever happens in the next hour and a half, you can be proud of the achievements that you've accomplished so far. I look forward to seeing you on the other side. And I only wish that the rest of our team could be sharing this moment with us. This is a very unusual event. This room is only half as full as it would be if we weren't in this pandemic. So missing everybody on the team who's not with us here today. And go EDL.
Welcome to the EDL family.
Godspeed, Perseverance. All right, activity. Go ahead and continue the report.
Sure thing, Flight. We've since completed the EDL start anchor. As I was mentioning, we changed our CBM row to EDL reserve two-way non-coherent. That row reinforces our CBM windows disabled, keeps our packetization on, it turns off our ranging and switches to the auxiliary oscillator. We have also started our real-time data products and reinforced Medley on. At this time,
Now, we just heard Perseverance team leaders thank the cruise team for their work in guiding the rover to Mars. Now, did you know the rover name and Mars helicopter name came from students? Well, a couple weeks ago, Marina was able to catch up with them.
Thanks, Raquel. Earlier this year, NASA and our partners held a nationwide essay contest to name our Mars rover. Alex Mather, a 7th grader from Springfield, Virginia, submitted the winning essay that was selected by NASA from a field of more than 28,000 entries from K through 12 students in every state in the U.S. Vanessa Rupani's essay for Ingenuity was so compelling, NASA thought it would be a perfect name for the history-making helicopter, a technology demonstration carried aboard the Perseverance rover. Alex and Vanessa join us now. Welcome, you guys.
Hello, space nerds.
Hi. Now, you got to go to Florida and watch the launch live back in July. Alex, what were you feeling as you saw that rocket launch into the sky?
I read a log of books written by astronauts, and every single one of them always talks about the raw power behind a space launch. And I definitely feel like watching the launch invoked that sense of inspiration mixed with anticipation, along with that rumble in my chest.
That's very inspirational, and I'm sure that you have had many conversations with your classmates since this all began. Now, what kind of questions have they asked you?
I got some people asking me about what this helicopter is, what this rover is, what are they actually going to do. So I love that this whole experience sparked a greater interest in the mission in my community.
Why do you think it's so important for kids to be inspired by space exploration?
Because space is the future, and kids are the future. Learning about space and watching the story of humanity spread to the stars happen is watching the future happen, seeing history unfold.
The best way to keep our home safe and protect our planet is to learn from the worlds around it. So I think it's really important for the next generation of scientists to be engaged in that type of exploration to make our home the best place it can be.
Now, speaking of the future, what has your life been like since naming the rover and helicopter? Has it sparked any future aspirations for the two of you?
Oh man, I am currently applying to a science and technology school for high school. I'm hoping for a NASA internship sometime along the way, with my ultimate goal being to join the incredible team of scientists and engineers who are about to make this happen.
This whole experience has definitely shown me that I want to go into the space industry. I came home from Florida, did all my college applications, and checked aerospace engineering on all the boxes. I mean, the whole time we were there, I was thinking, why would anyone want to do anything?
So true. And the best of luck to both of you. Thank you so much for joining us here today, Alex and Vanessa.
Thank you for having us.
Thank you so much. I had a great time.
Now, your essays, as well as the top 155 finalist essays, are riding on the Perseverance rover, along with nearly 11 million of the names from all over the world that were submitted before launch. And if you miss the chance to get your name on Perseverance, then you will get another chance to reserve a spot on the next mission to Mars. So make sure that you sign up now at mars.nasa.gov for your boarding pass. As virtual celebrations are happening all over the globe, let's take a look at some of your submissions on our social channels, showing us how you're celebrating the Perseverance landing right now. And remember to hashtag Countdown to Mars and send those in. We would love to show them off. Look at these kids. They are getting so excited. Everyone's watching it. A lot of classrooms are watching it. Oh, and great. Someone did a Lego version of Perseverance, which is awesome. It looks fantastic. We love getting all your pictures out there. We've gotten a lot of artwork from kids, which has been great. I know I have a 9-year-old John at home, and he loves to draw the rover. And look at that. That is awesome. That's better than anything I could bake, that's for sure. Perseverance in a cake. That looks so great. Delicious. I want to get into that. Another great send-in from David Bowie Reel. Thank you so much for your submissions. Remember, hashtag Countdown to Mars. We love to see how you're celebrating. Now, you might know our next guest from shows like Emily's Wonder Lab. Joining me now is Emily Kelandrelli. Thank you so much for being here with us today.
Hi, thanks so much for having me.
Now, you are very passionate about getting kids interested in science and space exploration. Why do you think kids are so excited about space?
Well, I know the reason I'm excited about space, and I think it's the same reason that many others are excited about space, and it's that the people in the space industry work to answer two of the biggest questions that humans have ever asked. Are we alone in the universe, and where did we all come from? And by sending a rover to Mars, we are gaining evidence for the answers to these questions, more evidence than we ever had before, and I think that's so exciting.
It is, and I know you get loads of interesting questions from kids. Have you gotten any about Mars specifically?
Oh my gosh, yes. Everybody loves Mars. It's in movies and books and TV shows, and everybody loves Mars. So one of the things that I get asked a lot is that, it's called the red planet. Why is it red? Well, it's red because it's literally rusty. The top layer of soil on Mars has iron oxide in it, or rust, and rust has that brownish red color. So it's red because it's rusty. And also because it's red, they ask, is it red hot? Is it really hot on Mars? And well, no, actually, it's colder than the Earth. It's farther away from the sun. So as you would imagine, it's a little bit colder than the Earth. It also has a really thin atmosphere. So the heat that it does have, it has a hard time keeping in. And so it's a little bit colder. But then I also get asked, what would I weigh on Mars? That's a really fun question. So on Mars, it's a little bit smaller than the Earth, so the gravity there is weaker. It's about 3/8 the gravity that we have here on Earth. So if you weighed 100 pounds here on Earth, you'd weigh 38 pounds on Mars, or 100 kilograms here on Earth, 38 kilograms on Mars.
Those are all super fun. I think even some adults want to know the answers to those questions, Emily. Now, why do you think it's so important to educate kids about science and give them that great foundation?
Well, science is the language of nature, and learning about science and learning how to think like a scientist means you are learning how to systematically seek out truth in the world. You are learning the scientific method. You're learning how to be a critical thinker. And honestly, those skills are great for whatever you end up wanting to do in life.
True. If you want to be a scientist or an opera singer, that holds true. And what are you most excited about today?
I mean, humans are launching a robot to Mars. That doesn't happen every day. I think in all of the hecticness that is going on today and all of the nerves, I just hope everyone can take a moment to sit back and remember that we live in a time when humans have the ability to send a robot to another planet. And that's so cool to me.
It is very cool, Emily. Take a deep breath. Thanks for joining us here.
Thanks for having me.
Sending it back to you now, Raquel.
Thanks, Marina. We are offering lots of ways to ride along with us to Mars. Now put yourself right into the action now with our Perseverance photo booth. You can pose next to the rover, place yourself in our mission control, and even see what you might look like taking a selfie on the red planet. There, you'll also have a chance to sign up to send your name to Mars on NASA's next flight to the red planet. It's all available at go.nasa.gov/Mars 2020 Toolkit. And joining us now is JPL Chief Engineer and Landing Veteran Rob Manning. He will be breaking down key moments coming up, and very few people know more about landing on Mars than Rob, going back to the Pathfinder mission in 1997. Thanks for joining us today, Rob.
Thank you very much, Raquel, for having me here. And what a wonderful experience. What a wonderful day for a beautiful day in California. We're just also excited here, anxious, worried, but very hopeful.
Rob, I have a question for you. There is a landing tradition at JPL that involves eating peanuts for good luck. Can you tell us how did that start?
Yes, it started in the mid 1960s. What happened was we had a series of missions that had failures. The Ranger program in the early 1960s, one after another, failed. And what happened was one day a fellow by the name of Dick Wallace on Ranger number 7, on the 7th attempt, decided to bring peanuts to the ops area just before the launch. And guess what? That mission worked. Now, we're not supposed to be too superstitious. We're engineers and scientists after all, but we love tradition. And ever since then, before launch and before critical events like entry, descent, landing, we have brought out peanuts and shared them with the team. And it's been really a wonderful little experience. And so this is something we will do. We're doing right now. And it's something that we just can't help ourselves. It's just part of the experience.
Oh, well, speaking of the experience, how did the Perseverance team keep the tradition alive this year?
Well, this year we're passed out little packets of peanuts to the team, and they can sneak one peanut in their mouth as part of to keep the tradition alive. But this is part of the COVID experience, but we can't leave this one undone. So this is what we're doing, and this is going to help us land safely.
All right. Thanks, Rob. I have some questions for you a little later on, but we're heading back to Swati Mohan, who is part of the landing team. She'll be calling out key milestone and events as they happen from Mission Control. So let's listen in right now.
So right now we're still about 20 minutes from entry, and the EDL phase is giving a last minute confirmation of what will be happening in the upcoming changes to the vehicle, just to remind the team.
And this will allow us to steer our trajectory as we make our way through the atmosphere. This is one of the things that allowed MSL, the Curiosity rover, to land where it did. And we're depending on the same type of entry guidance this time around to help get us very close to our target. As we make our way through entry, finish our guided entry profile, we'll do a maneuver called heading alignment, where we point toward the target and get ready to deploy the parachute. But before we deploy the parachute, we need to get rid of a set of balanced masses that have been giving us a center of gravity, or CG offset, throughout the guided entry phase. So these are called the entry balance masses. We also call this maneuver SUFR, S-U-F-R, or straighten up and fly right. So we'll go ahead and eject those masses when we get a trigger from the GNC system telling us that we're at the appropriate range to the target to do so. As soon as we deploy those, we will no longer have a CG offset, and we'll be ready to deploy the parachute 17 seconds later.
Right where the Perseverance team is sitting now, what's in store for them as we approach landing?
I'm going to hold here for video prep as we're about to start that anchor.
Copy, phase 2. And activity, please call that out when it's ready. Copy, flight.
Can I make the announcement now? Go ahead. Maggie's make the announcement, but
All right. Now, Rob, you've been right where the Perseverance team is sitting now. What's in store for them as we approach landing?
Well, this is the nail-biting time. Fortunately, we still have ones and zeros coming, but very soon, as we approach cruise stage separation, the transmitter on this rover we've been using all the way to get to Mars is going to be turned off. So we will lose our ability to see ones and zeros. But the good thing is, once the cruise stage is gone, there's another radio that will continue transmitting a tone, so that like a flashlight, that will allow us to at least see that the vehicle is still on, and that color of that flashlight tells us a little bit what state the rover's in. But soon after that, it won't be very long before we'll be able to hear more ones and zeros coming from the spacecraft. So this is a really exciting time, and it's just important to remind people this is there's a lot that can go wrong in a day like today. There are thousands of things that have to go right.
Yeah, we had success in the past landing on Mars. You'd think it gets easier, but it really doesn't. Why is it still so difficult?
Well, it's because it's involved thousands and thousands of things, hundreds of thousands of lines of code. There's 79 pyrotechnic devices. Each have to work perfectly. One critical wire short or one key thing mechanism that doesn't work or breaks, and it's mission over. And so it's, and it's very easy. We're human beings. We're not perfect. Mistakes can be made. We count on each other to find our own mistakes, and we work very hard to learn from the mistakes of the past. We've had many failures. Remind people, roughly half, around half of the missions to Mars over history have failed. And so it's that could happen today too. Even though we've had a nice, wonderful string of successes in the United States, it's still still a bit of a gamble that we have hoped that we have erred in the side of luck, and we've stacked the deck and loaded the dice to make this thing succeed. But if we do fail, and something bad happens today, I can tell you, we're going to learn it. We'll have the data that tell us what happened. We'll know why. We'll figure it out. And if we are allowed, we will pick ourselves up and get us back on the horse. And if Congress and NASA allow, we will try again. As we always do, we will learn from our mistakes.
And what are the possible scenarios we could be looking at today?
Well, there's things like one of the key stressful elements for all of us is parachute inflation. But just even separating from the cruise stage is a pretty major event. Lots of devices have to work properly. Certainly, the heat shield separation, getting the descent engine started. There's no less than 16 rocket motors that have to work. 8 to control during entry, another 8 to control it during landing. I said it's a lot of stuff, and it all has to work. And guess what? We haven't done this before with this vehicle ever. This is its first attempt to actually land. We can't try this on Earth. We can't we don't have test pilots to try it out on this planet before the big show. So this vehicle is doing it for the first time. We've done the best testing we can do in bits and pieces, but it's as best as we could do. But I think our team is up to it. This team is the best. It's a diverse, intelligent, amazing group of people.
Hey, everybody, we're back. Candice and Brad here. We've been watching along with you and putting up some comments and taking some questions. And Candice, we've seen some pretty good questions from a lot of people watching the stream. And I will tell you, we're about 20 minutes away, so we are not going to go away from showing that screen. But what we're going to do, we're going to chat for a little bit, answer some questions, and then we'll go back to NASA because the time is coming up around 3:55, right? That's kind of what we're looking at. And I got to do the news. So yeah. I can't be here the whole time, but we'll probably, my news director just said, once we get to that, when it's descending, we're probably going to do some talkbacks on air on TV as well. So I would have your TV screen and maybe the stream up at the same time, the 2-screen experience going on. So let's, Candice, let's approach some of these questions. Let's see. Some of the questions we've been getting have been pretty good. What are some of the ones you've noticed?
So right here on your screen, Kathy Fowler says, how long will Perseverance be on Mars? So right now, there's no expectation to bring the rover off of Mars, but the mission is supposed to last 1 Martian year, which is about 2 Earth years long. So that's how long the mission will be. But they may extend it if everything looks good after that.
Wow. Yeah, I think that's a lot of money that's going to sit on the Martian surface forever, right?
Right.
And just like in the movies, when we go there, it's still going to be there. Well, hopefully, who knows? A storm could pick it up and bury it or something.
You never know. Let's see. We've got a question here from Grayson. How far is Mars from Earth? So this mission is 300 million miles. Now, Mars can be a little closer to us because both Mars and Earth are moving. So sometimes we're closer, sometimes we're further away. But the entire mission, the spacecraft has traveled is 300 million miles.
Wow. Yeah, that's why, they launched back in July and we're landing today in February, which is pretty amazing. I mean, that, in the grand scheme of things, that's pretty quick, to be honest with you.
Yeah, exactly. how long did it take for Perseverance to get to Mars? So just like you were saying, Brad, it took 7 months. So we launched it back in late July, and it's landing in like 20 minutes or so, 19 minutes away. That's exciting.
Yeah. If you get a chance, go back and watch the launch, because it was pretty cool to see that go. Because the difference thing about, I mean, we've seen a lot of launches, right? A lot of satellites, a lot of missions to the space station. But what I found interesting about this launch is, they're not going into our orbit, they're going to another planet. So the way that they slingshotted kind of around the Earth to get to Mars was pretty fascinating to watch. So if you ever get a chance after this is over, there's some video. It's just a different maneuver in a different way. They actually did a pretty long burn once they were outside the atmosphere, which was really, really kind of cool. You could see some of it live until they went to the animation, but that was a really cool part of it.
Yeah, and what's really cool is like when this thing lands, it's going to take 7 minutes for it to go from the top of the atmosphere to the ground. And so I have a little experiment you guys can do at home along with us. So when it encounters that atmosphere, it's going to encounter air, and that's going to create friction. So I want everybody, guys, put your hands together, and then I just want you to rub really fast. And do your hands feel really warm or really cool? And they should feel warm. And so friction creates heat. And that's why that heat shield is on the spacecraft. So it'll actually heat things up to about 2,400 degrees on that heat shield, but the rover will get to about room temperature. So that's a really cool thing to think about. It's like that heat shield works wonders.
Yeah, and the landing should be pretty cool. I think when you see the animations, it's kind of like, it's just not the rover. There's actually what they call a sky crane, right? It's going to be taking it down to the surface and dropping it off to give it hopefully a nice soft landing, which is pretty cool. It's just, I think you envision, most people think, oh, they're just going to drop this thing out with a parachute or something, and it's just going to float down. But there's actually got another craft that's going to take it down to the surface, right?
Yeah, so the heat shield's going to help, kind of when it starts creating friction, it'll slow it down. It actually does deploy a parachute. It's 70.5 foot wide. And that'll bring it under supersonic speeds. So that'll slow it down to about, I think, like 200 miles an hour. And then 8 retro rockets are going to fire, and that'll help slow things down to about 2 miles an hour. And that's when that sky crane is going to just lower the rover and just boop it right there on the surface.
Yeah, and that's amazing. We're doing that all the way from Earth. I mean, that is just... that's the amazing thing about it. And we talked about this earlier for folks who didn't see, but there's a lot of, I wouldn't say like AI going on here, but there is kind of there's going to be some adjustments that are going to be made on board during the landing, right? So even the folks at NASA don't know exactly, and JPL know exactly where it's going to land, because it might have to adjust because the landing surface might be uneven, or there might be a boulder, so it's going to do some adjustments on the way down, correct?
Yeah, so this whole thing has to do it autonomously, so by itself. Yeah. So it takes our communications about 11 minutes to communicate between Mars and Earth, and the whole landing sequence is about 7 minutes. So you may have heard the term 7 minutes of terror. It's just where the entire NASA building is going to be holding their breath, just waiting to see what happens. So this thing has to course correct and land itself, and so it's going to have a camera that'll shoot down and look at the surface, and it's like, oh wow, there's a boulder there, I shouldn't land there, so let me course correct over a few feet. So it'll kind of determine what's the best spot to land there.
Yeah. Now the sky crane, where is it going to go? Where's it going to go? Is it going to go back up?
Yeah, so it'll just kind of fly away. It goes away from the rover, because you don't want that sky crane to actually get in the way of the rover stuff. So it'll land, and then it just kind of shoots off to another location away from the rover.
Gotcha, just to kind of get out of the way. And then how long do we expect it'll take for the rover to power up and start sending back? I mean, initially it's probably going to send back some kind of diagnostics or some kind of data feed to say, hey, here's the systems, everything's optimal, this is what's running, and then they'll start some kind of startup process, I assume.
Yeah, so we're going to have that 11-minute delay, but pretty much, as soon as it reaches the ground, it's going to be starting all of its boot up processes here. And NASA's going to go through probably an extensive checklist. Did anything get jostled, damaged? Are all the cameras, is all the systems firing up correctly? And that's what they're going to go through that checklist. And then from there, I assume they're probably going to take a picture and post it out on social media. We were talking about that earlier. I feel like that's going to be the number one thing, once they go through all of the protocols that they need to make sure everything's working correctly.
Yeah, and I think we all understand there's going to be solar panels to power a lot of this, but you mentioned something I thought was really cool is there's a small little plutonium-based generator, like a power source that's not solar in case they get a dust storm and they can't get solar energy for a while, or they have to, who knows, maybe they have to move it to a location to shelter it from a storm or something that they don't have enough power to do. So that's pretty fascinating. So there will always be some source of power on board, correct?
Yeah, so we learned this, like you learn as you go. So we had solar power, just solar panels on some of the previous rovers, and we realized, hey, when there's dust storms, this doesn't really work out very well. So you learn as you go, and so it has that like backup thing that's going to help it, continuously be on its mission, no matter if it's night or day or cloudy or dust storms or whatever.
Yeah, and that should really extend its life, I would think, too, because I'm sure there's batteries on board as well that'll be able to charge when there's solar power as well. But that's going to give it some time, because I do remember some of the previous missions where, they'd lose contact for days because there'd be a storm or something. It could be in the middle of doing some research, and then it's like, and sometimes they didn't know, was it dead or did something happen? Like, oh no, we just lost power for a couple days. And it would come back on.
It's like losing signal on your phone. You're kind of sitting there like, hello, are you still there? And then like all of a sudden your friend like picks back up and you're like, oh, thank goodness. Like same kind of thing. I think we had another question. Charlie was asking, who's controlling Perseverance? So we were talking about Perseverance can, kind of do some of its own decision making, but generally it's the people at NASA. So they're going to, once they kind of figure out where they're located, what orientation they're in, they'll kind of take a look and say, oh, okay, it looks like over to the right is going to be a good area to look at. So they'll kind of help drive the rover, but the rover also does some of its stuff itself as well.
Yeah, and we've got a lot of smart people at JPL and NASA that have mapped a lot of Mars surface already. So they probably have a blueprint or a plan of what they want to do, like what areas they want to check out, what area. But here's the thing, in science, you have a plan. And sometimes once they start seeing things, they might change that plan because they say, oh, look, there's some discolored soil over here, or we see something that looks interesting. So they might end up going off blueprint or plan if they see something they want to investigate. But that's the beauty of science. They're going to kind of, they've got a plan, but they've got the ability to kind of break from that if they have to.
Yeah, and one thing about these rovers, even the ones that are on there, they don't move very fast. We're talking like, very, very minimal movement. So it's not like this thing is going to like rip around the planet over the next, Martian year or 2 Earth years. It's really going to stay within this 28-mile crater. And so it's just going to investigate this little area there. And, so like you said, they do have the ability, a few feet over, it looks a little different. Like, oh, okay, well, we might can go explore that. But like you said, they do have a plan, and they're going to try to execute that plan to the best of their abilities.
Yeah, I mean, the way I know NASA works, you've got different people in charge of different parts of this, right? There was the launch part, there's the travel, there's the landing, and then there's a whole nother group of people that their job is just once it gets to the surface, this is what we're going to do. So, and while all those other people are working on the other projects, they've been working on their project for the last who knows how many years, so they've got these plans ready to go. So they'll be like, all right, lander people, get over here. The soil people, they're going to have the atmospheric people, they're going to have all these different specialties that are going to start looking at stuff. So we're coming up at around, it says 4 minutes, which is going to be interesting. I think that's when the landing process starts.
That's probably when it like starts entering the atmosphere.
Yeah.
All the 7 minutes of terrors is going to start.
So we got that 7 minutes on top of that. So that makes sense because that would be around 3:55-ish or so. So we seem to be on schedule, which is amazing considering this has been planned so far. Right. And, we expect 3:55. Who knows? It could be a little later or a little bit sooner. But so far it looks like they're on schedule. So we're going to take a couple more questions, and I'm going to have to go do my day job here, which is the weather. Candice is going to stay watching this as well. We will as well. We're going to keep this stream up, and we may jump back in. But if you want, please shoot your questions in here. We're monitoring this. We've got James and Candice in here keeping an eye. I'll be in between weather hits. I'll be checking it out. And on TV, if you're watching WCNC, if this is something happens cool while we're in the newscast, we are gonna talk about it on air and bring in some live pictures from NASA. So please keep those questions coming.
Oh, we got a question here. Addie, age 7, would like to know how spacesuits work. Oh, that's a good one. So spacesuits, especially like the ones that the astronauts have wore to the moon, not only are they protecting them from the vacuum of space or giving them air to breathe, but they protect them from these things called micrometeors. So like little pieces of rocks, which doesn't sound like a lot. Think about like if someone blows dust in your face. Well, on the moon, that can be a really bad thing. So it protects them from micrometeors and protects them from the sun's radiation as well. So not only that, but they also make them look cool too.
Yeah, I mean, you think of all the things you don't think about in space, like you said, objects in space, because there's no gravity or friction. Once they go in their forward motion, they go at that speed until they hit something. So
yeah, exactly.
A little pebble, can go at the speed of a bullet. They can fly if nothing slows it down until like it runs into something or it gets into gravity or an atmosphere slows it down. We take for granted some of the things we have on Earth. It's a lot different up in space. Even like you said, UV protection, we need to wear sunscreen on Earth, but we got the atmosphere that helps us out a little bit. In space, you don't have that atmosphere.
Yeah, you lose all the protection that naturally comes with it. So you can get burned very easily if you don't have your protective gear on.
Yeah, the extremes of space and some of these planets is amazing because, like we've seen on Mars, in the middle of the night, it's 60 or 80 degrees below zero, and then during the day it recovers back to tolerable, what we would think is a spring day, and it will do that all in a 24-hour period. So
I always tell people, if you think North Carolina's weather is crazy, please come talk to me in the Sky Tonight show here at the museum, because I will show you how crazy weather can be on other planets, because we really don't have it that bad.
Yeah, it is crazy. So I'm gonna have to jump out of here, Candice. She's gonna stay watching kind of online as well as we get going. There are 30 seconds from this thing starting. So James, we'll let you go back to NASA. Thanks again, Candice. Love it. The Schiele Museum's great. If you guys get a chance, go check them out. But we'll be monitoring this. Please enjoy this, because this is going to be an amazing event. And now we're getting close, Candice. I'm getting excited here.
I know. This is going to be great.
Yeah. Have fun. Enjoy it, guys.
5.3 kilometers per second and an altitude of 150 kilometers from the surface of Mars.
Entry.
We have confirmation of entry interface. Perseverance is currently going 5.3 kilometers per second at an altitude of about 120 kilometers from the surface of Mars. The spacecraft is now waiting until it begins feeling the atmosphere of Mars to slow it down. Once there is enough atmosphere, it will start controlling its path to the landing target. Navigation is also confirming that we can see a little bit of that slowdown of the atmosphere on the Perseverance entry capsule. Our current velocity is about 5.36 kilometers per second and an altitude of about 67 kilometers from the surface.
We are probably seeing MRO plasma blackout at this point.
The vehicle should be doing its turns right now.
MRO has lost lock.
Perseverance. We have indications that Perseverance is now performing bank reversals in the atmosphere. These are the steps in order to control its distance to the landing target. Perseverance has just passed through the point of maximum deceleration and has indicated that it felt approximately 10 Earth Gs of deceleration.
MRO has lock again.
Yes, 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 yes.
We saw a small outage
of the UHF telemetry from Mars Reconnaissance Orbiter during that peak heating phase, likely caused by the plasma blackout. Perseverance is still continuing to perform bank reversals in the atmosphere to control its distance to the landing target. Perseverance is going about 1 kilometers per second at an altitude of about 16 kilometers from the surface of Mars. We have entered heading alignment, which means Perseverance is no longer trying to control the distance to Mars, to the target on Mars, but instead is flying straight to the target.
Parachute.
Our current velocity is about 550 meters per second at an altitude of about 15 kilometers from the surface.
MRO's reporting good telemetry log.
We are coming upon the straighten up. We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Yes, yes, yes.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars. Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Yes, yes, yes.
Perseverance now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
Almost there.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Yes.
We have timing of the landing engines. Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about 1 kilometer off the surface of Mars.
TRN Safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver.
We've lost direct to Earth tones.
As expected. As expected.
Sky crane maneuver has started. about 20 meters off the surface.
We're getting signals from MRO.
UHF is good.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life. At this point, the descent stage has flown away to a safe distance. Perseverance is continuing to transmit direct through Mars Reconnaissance Orbiter to Earth.
Oh my God. Oh. Oh.
MRO reports they're still getting telemetry from the lander.
All right, all stations.
We got it.
Touchdown confirmed. We're going to wait for the images.
Wow.
This is so exciting. The team is beside themselves. It's so surreal. Stay tuned. We might get some pictures.
That'd be great.
So much has been riding on this.
Yeah, we just heard the news that Perseverance is alive on the surface of Mars.
It's not
Flight, we have seen the completion of EDL 3000. Copy activity. That is as expected.
MRO is still seeing a strong signal from the lander.
We have just heard the news that Perseverance is alive on the surface of Mars. Congratulations to the mission. And looks like we have some more news in. It looks like we're getting the first image. Here, take a look at the first image.
Flight, this is OL3. I have the target point on the map when you are ready. We are ready, OL3. Go for it.
Wow.
Flight, I'll be moving in, showing you the safe zone that we've landed in.
The team has just put the first image from Perseverance on the surface of Mars. Now, it comes from the engineering cameras, known as the hazard camera. This camera is mainly used to help the rover drive safely around Mars, and we will get higher resolution photos later in the day.
Look at that, right? You get the safe.
Wow.
Let's see our info.
Nice. This is amazing.
Here's Andrew.
For Steve. Stand by for Steve.
You did it. You did it. You did. You led the team. You made it happen, man. Congratulations,
second image in. Our second image is in.
Okay, these we have a camera in the front and rear of the spacecraft. They're near the ground, so these are pretty close. So you can see the wheels there, and they're a little dirty because we've got glass covers over these cameras. But we took these seconds after landing, so there's still dust in the air from our landing event. So this is happening. This happened just seconds ago. Just arrived, and this is really amazing. And we even know where we landed. This is the most amazing thing. The vehicle has told us where it's landed because it figured it out. This is a sign. NASA works. NASA works. And when we put our arms together and our hands together and our brains together, we can succeed. This is what NASA does. This is what we can do as a country on all of the problems we have. We need to work together to do these kinds of things and make success happen.
Yeah.
And joining us now is the acting administrator of NASA, Steve Jurczyk. Steve, welcome and congratulations.
Hey, thank you. What an amazing day.
And how does it feel to have another rover on Mars?
It's amazing to have Perseverance join Curiosity on Mars, and what just a credit to the team. I mean, just what an amazing team to work through all the adversity that goes and all the challenges that go with landing a rover on Mars, plus the challenges of COVID, and just an amazing accomplishment.
And what does this mean for NASA and its future plans?
So for robotic exploration, every time we execute a mission with new instruments, we discover new things and things we never thought we would discover. So that always informs our future robotic missions, both landers, rovers, and orbiters. This mission also has technology on it. One of the cool things is the Ingenuity helicopter. It's an experiment on this mission, but if it's successful, we can use it as an science observation platform by putting instruments on it, and also use it as a scout for future rover missions. And then just the entry, descent, and landing capability. It'll allow us to land more larger, more ambitious robots on the surface of Mars. And then for human exploration, we have the Mars Entry, Descent, and Landing Instrumentation, which is going to give us EDL information. We have the Mars Environmental Dynamics Analyzer. It's going to give us size and properties of dust particles, because when we send people, we're going to have to deal with that dust. This is just an incredible mission because of the science and the technology, and then caching samples for a Mars sample return mission. That will be an amazing mission, the first round trip to Mars and back, and bringing those samples cached by Perseverance back to Earth to examine with state-of-the-art equipment in our laboratories here on Earth.
We have so much to look forward to. And we also have a student question coming in from Landon. Let's take a look.
Hi, my name is Landon Applegate. I'm in 6th grade and I'm going to Academy for Academic Excellence. And my question is, do you think we could get resources from Mars to help on future missions, or even as like a launching point?
Great question, Landon. Actually, we have an experiment called the Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE, and it's going to demonstrate generating oxygen from atmospheric CO2, and that could help generate breathable oxygen, and even if we can liquefy it, oxidizer for propulsion systems. So that's a tech demo on Perseverance. And then we're going to continue to characterize the frozen water on and below the surface of Mars, and eventually try to figure out how to extract that water from the Martian soil, or what we call regolith. And then we can use that for potable water and also break it down into oxygen and hydrogen for rocket fuel. So absolutely, we're going to try to eventually figure out how to live off the land to support human missions to Mars.
Thanks for taking the time to talk to us today, Steve.
Thank you.
And now that Perseverance has safely touched down on Mars, let's learn more about what's in store for the rover. Joining us now is Surface Mission Manager Jessica Samuels. Jessica, your surface operations team has now taken over. What are they doing now?
Yes. Hi, Raquel. We are so excited here in the Surface Mission Support area. The team will do a handover with the entry, descent, and landing team and pass any critical information. And then this team behind us will be the team that does the health and safety assessments daily as we progress on this mission.
And what do the upcoming weeks look like for your team?
So as we enter Mars time now, the commanding team will be working overnight while the rover is asleep so that we can perform the initial checkouts of our key rover functions and our science instruments. And we have to do this all in time for the regularly scheduled communication pass, which happens in the morning. And so we will be working around the clock, making sure that Perseverance is healthy, and we will begin this exciting adventure.
And can you tell me, what's it like living on Mars time?
It's a little bit like constantly, flying and changing your time zone. The rover, on Earth, the rover wakes up at the same time every day, but on Earth, that's 40 minutes later. So the team is going to be shifting our work schedule by 40 minutes as we come into work over the next few weeks. So it'll be exciting and some late nights, but we're also excited and we can't wait.
It's a whole new lifestyle.
Yes.
We also have a student question for you. This is Sophia's video.
Hi, my name is Sofia Lopez, and my question for NASA is, how's Perseverance gonna survive? And here's a drawing that I made from Perseverance thinking about Earth. Thank you.
Well, Sophia, Perseverance survives with a power source that charges its batteries overnight while it sleeps, and it keeps heaters on so that all of our critical electronics can stay warm, as well as our mechanism. But it's really survived by the team that performs the health and safety assessments every day and communicates with the rover and makes sure that she's doing okay.
Well, thanks for your time, Jessica, and good luck living on Mars time.
Thank you. Should be fun.
Let's head back to Marina as she gives us a sneak peek into the future at JPL.
Thanks so much, Raquel. It's definitely bustling behind me. It's not quiet like it was just 20 minutes ago. And congrats to the whole team. What an amazing accomplishment. Mike Watkins is the director of NASA's Jet Propulsion Laboratory. He was the mission manager during the Curiosity rover landing on Mars. Welcome, Mike.
Oh, thanks. Glad to. It's one of the most complex robotic systems ever made, and having it down safely means Mars sample return continues right on course, and we are moving forward.
Wonderful. Now, JPL has a long history with robotic space exploration. Why do you think it's so important to continue to push those boundaries?
There's a lot of reasons. I mean, obviously, for places that are far away, like Mars, and even farther away, like Europa, right now, robotic exploration is the only way we can habitable environments. In the case of Europa, maybe it's even still habitable. And, we're not ready to go there with astronauts yet, but the robots are ready to go there. And so we always, are forerunners and pathfinders of human exploration. And we start by sending, our eyes and arms there in the form of a robot. And it is just fantastic to be able to do that and to learn from each rover, learn from the science and the engineering, and make the next one better and make more and more discoveries. And every time we do one of these missions, we make fabulous discoveries. And each one is more exciting than the last.
The future does look exciting. Now, as director of JPL, what would you like to say to those teams right now celebrating?
Oh, obviously they have earned it. Let me tell you. I mean, they have worked, for years and years on this mission. And then in the past year, of course, we had the COVID experience. And I want to thank not only the team, but also, all of JPL. A lot of folks had to pitch in here, in terms of making sure our remote telework, our IT systems were good enough to support folks working from home. All of the folks looking at PPE and our safe distancing and reconfiguring facilities to make them safe for the employees. It's just an incredible amount of work by the entire lab, and of course, especially by this team. And and in one sense, the 7 minutes of terror are very exciting, but on the other hand, the mission's just started, right? We built the mission, not to land, but actually to drive and get the samples and do other technology, demonstrations. And so, for much of the team, this part of the mission's over, but for most of the team, the mission's really just starting. And so, I think they're very excited, but everybody, I think, can take a deep breath and a sigh of relief now that we are safely down on the surface.
Yes, that collective sigh of relief. And I hear a lot of excitement and celebration behind me as well. So thanks so much for joining me, Mike.
It's my pleasure. And thanks to everyone for joining us too.
Congrats again to the Mars 2020 Perseverance team for a successful landing. Back to you, Raquel.
Now, there will be a flight test coming up for the Ingenuity Mars Helicopter. And if this technology experiment is successful, it would mark the first time we have taken a power-controlled flight on another planet.
Sometimes you have to do something just to show that you can do it. When the Wright brothers flew for the first time, they flew an experimental aircraft. And in the same way, the Mars helicopter is designed to show that we can fly powered helicopter flight in the Martian atmosphere.
From day one, this was the unwavering dream of our team, to get our helicopter launched to Mars so that we can get that opportunity to do the very first rotorcraft flight test in the actual environment of Mars. It's extremely difficult to fly at Mars because the atmosphere is so thin. Compared to Earth, at Mars it's less than 1%. So the first and foremost challenge is to make a vehicle that's light enough to be lifted. And then the second is to generate lift. The rotor system has to spin very fast. 2,000, 2,200, 2,400, 2,600. We're spinning between 2,000 and 3,000 revolutions per minute, and it takes a lot of energy. So it's that balance of a very light system, yet having enough energy that's needed to spin the rotor so fast to lift, and on top of it, having to design in the autonomy.
It has to be fully autonomous from the time it takes off to the time it lands. What we do on the ground is we plan the flights, and so we determine from here where we want the helicopter to go.
Our experiment window is 30 Martian days. So we have planned up to 5 flights of incremental difficulty.
The very first flight, the main thing is we want to get the legs off the ground. And so we will basically go up about 3 meters and we'll hover there and then we'll come down again. And that will be the first, really major milestone.
Most of our flights will be at the 3 to 5 meter height. We will be going horizontally again at a few meters per second, probably go out, 50, 70 meters and come back. In successive flights, we'll probably push that further, try to go further. So our priority will be to get back engineering telemetry and not so much images, but I'm sure we'll return a few, because they'll always look cool.
At this point, we've tested all we can on Earth. We have mathematical models that shows how it will fly at Mars, and we've tested it in the simulated environment that we can create on Earth. It really is time now to do the real flight test at Mars.
Nothing is a given, but we have done everything we can in terms of a test program here on Earth. The vehicle's performing extremely well so far. It's been doing exactly the right thing, even right now when it's bolted onto the Perseverance rover. So there's a very good chance that we'll pull it off, yes. but it's still high risk. And none of us forget that you could have a glitch that, could mean end of mission, yes.
It's going to be exciting, reacting to any surprises we have. We can't wait. What's really most important is everything we're learning here is for the future rotorcraft systems that we want to introduce into space exploration.
Mimi Ong is the project manager for Ingenuity. She joins us now as they await a chance to check out their helicopter in the coming days. Welcome, Mimi.
Thank you, Marina.
Oh my goodness, we've been talking about this for months, Mimi. Did you ever think you'd be here at this point? I mean, what's going on in your head right now?
This is super exciting. We have been working on Mars Helicopter for over 6 years, testing and carefully designing it for operation at Mars. So what's going through my mind? Ingenuity Mars Helicopter is finally at the destination that it is designed for.
Now that Ingenuity is on Mars, what is the timeline you hope to accomplish as you move forward?
We have a series of major milestones between now and Ingenuity's first flight. So tomorrow we'll turn on the helicopter and its base station to confirm health after experiencing the dynamics through the EDL just now. And the next major milestone will be when the rover deploys the helicopter to the surface. And that marks the first moment that Ingenuity operates on its own in a standalone manner. And surviving that first cold, frigid night of Mars will be a major milestone. We'll execute a series of checkouts, and then we will perform that very important first flight. And if the first flight is successful, we have up to 4 more flights in the 30 Martian days that we have set aside for our flight experiments.
And that's when you finally can breathe, right, Mimi?
Yes.
Now, why is it so important to have that aerial dimension to space exploration?
A helicopter flying far ahead of rovers and astronauts in the future can provide high-definition reconnaissance information for the rovers and the astronauts before they take the long journeys. And as importantly, being able to fly will enable us to get to places that we cannot get to with rovers and astronauts, like sites of steep cliffs, deep inside crevices, areas of high scientific interest. It will be game-changing.
Game-changing is
to bring back rocks that could answer whether life ever existed on the red planet. Ground controllers are at the space agency's Jet Propulsion Lab in Pasadena, California. I want to bring in Brad. Brad, you just got done talking with an expert from the planetarium at the Schiele Museum in Gastonia. Tell us more about what's going on right now.
Well, pretty exciting. I was kind of torn away from weather here for a second. We had a landing, a touchdown, and the first images now coming back from the Martian surface. And this rover is pretty amazing. It's about the size of a car. This is not a little, like, remote control little rover. This thing is monstrous. It's got a little drone with it as well, which is going to be the first flight on another planet. It's going to be able to take 90-second flights around this crater. And the goal is, Fred, to get some samples to see if there is life on Mars. And we're not just talking about, aliens here. We're talking about single cell organisms or some kind of bacteria, because the crater that they landed in was an ancient lake. So we know there was likely a water source there, and somewhere in that soil, we might have some kind of life. This is really an amazing achievement, Fred, because this was launched during the pandemic. Wow. The launch was actually last July in the midst of this pandemic. And in fact, on the rover, there's a small little plaque that pays tribute to all the healthcare workers. So it is pretty amazing.
Yeah, one of the things we take for granted, all of the developments in science that have been going on during this pandemic, simply amazing work going on.
Yeah, and they couldn't postpone this. There was some talk of that. The way you go to Mars, you've got a window that only opens up about every 26 months where it's possible. So if they would have delayed, they would have had to wait almost 2 years to do this again. So it really is a huge achievement. If you're online, go check it out. It's on my Facebook page or our YouTube page as well. It is spectacular. We should get some 4K images, Fred, believe it or not. That's the difference about new technology. 4K images coming in from the planet, hopefully here in the next couple of hours.
the vehicle perform. And as you saw Bob Belram in the video before, we will be taking a few first ever color pictures from the flying aerial vantage point, but they'll be icing on the cake. For this one, this is all about engineering data and how do we fly compared to all our tests we have done on Earth.
Mimi, so much for your team and the future generations of scientists and engineers to look forward to.
Thank you.
Thank you so much for joining us, Mimi, and good luck to your team with that first test flight.
Thank you so much.
Now, we look forward to the Perseverance rover and Ingenuity helicopter beginning their journeys on Mars as their adventures are just about to start. Go Perseverance and go Ingenuity. Back to you, Raquel.
Thanks, Marina. Landing on Mars is never easy, but this team has persevered, and NASA's 5th rover is on the red planet. You can still hear them buzzing in the back right now. And to get the latest updates on Perseverance as it explores Mars, follow @NASA Persevere on Facebook and Twitter. I'd like to thank everyone watching for joining us today. And to the students and teachers tuning in, we hope you learned a lot from today's landing, and thank you for all your questions. We have a news briefing coming up at 2:30 p.m. Pacific time. That briefing will wrap up the day and include reactions from Perseverance team members. We'll leave you now with some of the landing celebration photos you've shared with us, set to Youngblood's cover of David Bowie's Life on Mars. I'm Raquel Villanueva. Thanks for watching.